Hey guys, good evening. I hope I'm pretty much audible as well as visible to people here. So, hey guys, good evening. Just gonna start up the things here, guys, just for a minute. As well as visible to people here. Okay, so looks good. I think we're good to start. Okay, so if you would have remembered, so in our previous class, we were talking about prominently towards the solution journey, right? And in that solution journey, we have been talking about a lot many things. So how a data solution starts, so the data collection step, and then we process it, we analyze it, and then we eventually build up the model, we communicate our results, and then we get the implementation done, the deployment done, right? So all of these are obviously interconnected. That's where we call them as my specific journey of a problem statement, right? So now, today we are going to specifically move towards one of the type of our problems, which is regression. And so in machine learning, we have been discussing about in one of our classes where what are different type of problems you can think of in data science and specifically on machine learning. And then from this machine learning perspective, how exactly you can imagine the questions and how you can imagine the problem statements being evaluated. So that's where the index of regression comes into picture. So we have been talking about this as well. So that's going to be our pretty much the agenda for today. So we'll be going in detail about my regression problem statement, try to understand the problem statement is defined in a regression type of a problem. And once we have defined the problem and we have framed out our solution to that, so how are we going to evaluate that problem statement? So that is again going to be one of the points for the discussion today. So we will be going in detail for our regression type of a problem. So what is used in regression? So what do we do, and how do we evaluate our model? So indexes, by indexes I mean here, I will be focusing around the evaluation strategies which is used for my regression type of problem. So that is primarily what the agenda for today will be. Cool. So without wasting much time, so let's get started as always. So yeah, so that is going to be our agenda as I've said. But before that, my name is Arpit Jain, a quick introduction about myself. And the reason why I'm here with you all because data science is purely what my passion is. And I really like sharing my expertise with people around me, right? So where I really talk about the data science stuff and then where how we can identify a problem statement, how we can solve a problem statement. So a lot many things. So there's so many things which is involved in data science. So we will be talking about them one by one, and that is going to be the agenda of the day. Right. So that is who I am, and also along with this, I'm pretty much a motivational speaker as well. So I do talk to students regarding their career, job placements, and carrying them around. So please feel free to reach out. Yeah. So from the agenda perspective, as I was telling you, so we will be discussing about first about my the machine learning part. So we'll quickly discuss around how machine learning is prominently getting used in our industry. So we'll give you a quick walk around of the machine learning statement. So we have already taken this, but again, we will talk about this a bit. So we'll try to understand how machine learning problem statements are defined and where we can use our machine learning for the objective, and what is a regression based problem and how we can use the different matrices in the regression-based problem to identify our solution. So that is again going to be our agenda for this week, today's class. But again, before proceeding further, I would like you to first again take a quick refresher on machine learning. So if you remember, I have told you machine learning is basically one of the parts of subdivision of my artificial intelligence, right? So artificial intelligence broadly is of two types, as we were discussing earlier as well, strong AI and the weak AI, right? So strong AI, where we talk about the robotics, we talk about open-ended problem statements, right? So we are focused around mimicking my human brain, which can do every single possible thing, right? That is where machine learning comes into picture. That is where we talk about artificial intelligence, strong artificial intelligence, robotics, artificial general intelligence, AGI, that's what we call this as. And the second is the weak AI, where we are primarily focused on one problem statement and we're trying to solve only one problem at one time. So that is what, coming towards my weak AI, and then we talk about my parts here in this part. So, and the weak AI side, machine learning, that's where it comes into picture. In machine learning, again, we saw a further subdivision where we saw two types of machine learning problem statements. First is supervised. Here we saw labels present here. And second objective, we saw unsupervised. And it's all about no labels here. That's what the prime distinguishing between my machine learning objectives would be. And in the supervised also, we saw two prominent subdivisions. That's where a classification type of a problem comes, and the second is regression. So basically, regression is part of a supervised mechanism, which internally is part of my machine learning. So that is what now today we will be focusing around the regression matrices. So once I'm not going into the detail of the machine learning algorithms right now, but rather assuming that with the different algorithms you have available in regression, you have built up your model and now you're trying to evaluate it. So what kind of metrics would be required here? So key metrics would be discussed for our pointers today. So that is where we will be going in deep, right? But again, obviously, I'm going to give you a quick refresher of supervised machine learning, classification, regression type, so that we can relate to our agenda for the day. Cool, guys. So with this, moving ahead, as you know, artificial intelligence is nothing but a set of algorithms and intelligence to try mimic the human intelligence. So very important terminology which comes here in artificial intelligence is human intelligence. So we are trying to mimic the human intelligence. And what is a human intelligence? Basically, we're trying to mimic the brain, right? So we are trying to copy the intelligence what a human brain has. How we are going to do that? With certain set of rules, certain set of protocols, certain set of algorithms through which we are trying to mimic how a human intelligence is working. And that field prominently is being referred as AI or artificial intelligence, right? And we already know that artificial intelligence is of broadly two types. First is AGI, which is nothing but artificial general intelligence, or we also term this as strong AI, right? And second is machine learning, where we call this as weak AI. So that is how the artificial intelligence concept has been structured. So artificial intelligence is nothing but a set of algorithms where we are trying to mimic the intelligence of my human brain. And machine learning now, as we have understood, is one of them, is one of the types of artificial intelligence. And deep learning, now there is another terminology. So machine learning, artificial intelligence, and then we come to call as deep learning. And deep learning is one of those machine learning techniques. So machine learning is nothing but certain set of algorithms and certain set of protocols through which we are trying to mimic the intelligence of a human brain, as simple as that, to solve certain business problems, obviously. So this is where I will be saying, so machine learning is one of the protocols, one of the algorithms, which is trying to mimic the human intelligence in a very narrow fashion here, only trying to solve one single problem. And deep learning is one of those machine learning techniques which is pretty much having, another set of algorithms which is again going along with my machine learning technologies. Cool. So moving ahead, giving you a quick recap of what machine learning is. So machine learning includes a section of AI, and deep learning is a part of machine learning. Very important. So we have to always remember this. So machine learning prominently includes one subdivision of my AI. So we have already understood, right? So artificial intelligence, that is where we have strong AI and the weak AI coming into picture. Strong AI is the one where we're trying to completely mimic my human brain, and we're trying to identify and we're trying to solve every single question from this, or every single thing which a human brain can do. Maybe I can walk, I can swim, I can drive, I can play cricket. So every single thing I'm trying to replicate, that is where robotics comes into picture. Strong AI, artificial general intelligence. And second, we have the weak AI, that is where we are trying to solve only a specific problem statement, and that is also called as narrow AI. And machine learning is basically where we're going to call the weak AI is being happening. So example of weak AI is machine learning, right? So what do we do in machine learning? We have to first understand this, right? So objective is to learn the data. So what do we mean by learning the data, right? Again, very important part. So when I say I have a data which is demonstrating any business, for example, I have a data from an online merchandise store where I have the transaction level information of every customer. So when a customer is buying a particular product, what is the price of the product, what and the demographics of my user, his past history and whatnot, right? So from all of these information, maybe one problem statement can arise that what would be the probability of any customer buying any product in future? Or if is into my website right now, is browsing any product, what is the probability of that user to buy that particular product which he is right now viewing on my website? So intent here from the machine learning perspective is to first understand the data and try to find out the hidden patterns through which we are going to now generalize the information. Like when we go to a doctor, so what a doctor says, right? So suppose I have certain illness, and then I go to a doctor, and then a doctor asks for certain symptoms. Okay, you have symptom 1, you have symptom 2, and you have taken your blood test. So and then blood test reports 1, reports 2. So by combining all of this information, the doctor is coming to a conclusion with the fact that okay, you might have disease A, B, C, D, whatnot. So how come he's coming to a conclusion? By the fact that he has all of these information based on this correlation which is available on this data, he's able to come to a conclusion saying that okay, this is the based on this facts, yes, you might have this disease, right? And how he has understood all of this, he might have learned this in his educational days, where he would have figured out, okay, this is the pattern. Okay, if this happens, this is the correlation to this. So basically, with the available set of information, he first understood the data. Like, okay, this is what it is, and based on this, this happens. And that is where now we are trying to mimic the similar things, trying to feed the machine and trying to give them all of those information which probably the doctor also might have learned. And based on those learning, I'm expecting this machine to also tell me, seeing those data, what is the probability and whether that person is having that disease or not. So learning the data is prominently talking about, generalizing the patterns and understanding what the particular data is talking about. And based on this, we're trying to give a meaningful business outcome. A meaningful business outcome is pretty much coming from this. Machine learning includes my pattern recognition. So we're going to talk about my pattern recognition, which includes the ability to recognize the patterns in my data. Right? So we are prominently talking about pattern recognition. So when I say learn the data, I am talking about how I have to do the pattern recognition. So based on this pattern only, symptom 1, symptom 2, symptom 3, there was a pattern which got developed, and ultimately this correlated with the disease ABC, right? And that is where, for whatever my business is, for whatever the business problem I'm trying to solve, based on this, we're trying to understand this pattern. That is what machine learning is doing, trying to read these patterns. And once this pattern has been identified, now we are generalizing these patterns and making sure that this is correlated with my outcome, which is maybe a disease 1 or disease 2 or whatnot. And here we talk about the patterns. The patterns should be trained to show the output in a desirable manner. So we are talking about training of these patterns now. So that is where actually machine learning comes. So once this pattern has been identified by the machine itself on the algorithm, now this pattern is what will be trained, and the machine is expected to behave and to show the output in a desirable manner. If it sees the similar pattern in future, then it should identify that, yes, if it is the similar fashion, it relates to this output. That is where the results comes into picture. That is where we say that, yes, this is what my machine learning output is. So machine learning is basically trying to see the pattern of my data, and with this pattern identification, it is trying to show me the output to whatever we need. And that is where, in terms of output, again, we have further segregation. So prominently, machine or the training method is of two types. First is supervised mechanism. Second is unsupervised training. Supervised training and unsupervised training. These are the two different ways in which a machine learning setup can be trained on. Okay. So, as a name suggests, supervised training, can we relate this as some sort of supervision? We have. So when we say some sort of supervision, what do we mean by this? If we have some sort of supervision, means I am being guided by something. Right? So if I have some sort of supervision, I am actually guided by something. So what do we mean by this guidance? What do we get out of this guidance? Right? So that is something which we have to understand it. So this guidance is prominently where we say that, yes, now Because of this, we have this supervision in hand, and we are now able to understand the training with this guidance which is available to us. And what is, in terms of data, this guidance called as labels. So we have something called as target. Whatever I'm going to achieve, that target is prominently being given at the time of training. So I know the factors. So basically my symptom 1, symptom 2, symptom 3, and report 1, report 2, and all that. So all of these, my parameters, it relates to disease A. So this correlation is already established. I have a data set where it says that all of these 6 parameters, it's eventually relating to a disease A. Likewise, I will have other symptoms as well, which will correlate to disease B. So I will have all of these things available. The supervision will be there with me, where I will be saying that, yes, I have a supervision in which I am being told what is required for me and what is being given. And that is where we talk about it in detail, right? So disease A, disease B is prominently what is provided to me. Okay. That is where machine learning comes into picture of supervision type. So we are talking about supervision, and supervision is where I'm going to say that, yes, I have a supervision in terms of my labels. I have the established correlations already available between my independent features and my target. And that is what is missing in my unsupervised method. So unsupervised will take it with time, but right now we are only talking about my supervised method. So supervised method, where we'll be focusing around the regression metrics now today. So a quick description of my supervised learning. So this method or the learning algorithm take the training data and its associated output, that is labels or responses, with each data samples during the training process. So prominently, what are we talking about here? So the learning algorithm, it is taking the training data and its associated output, that is my labels or responses, and it takes the data samples one by one likewise. The objective of supervised learning algorithms is to learn an association between my input data samples and the corresponding outputs after performing multiple training instances. So basically, I have a data set which is more like this. Imagine it's like a tabular data. Okay. I have feature 1, I have feature 2, I have feature 3, I have feature 4. And this is what my target T is. So I have my multiple columns. So I have the data sets available, the values available, and this relates to A and B or something else. So I have the target available correlated with my respective internal input feature sets. So that is what it means here. So the learning algorithm takes the training data and its associated output, that is the labels or responses, with each data samples during the training process. So we are going to talk about the labels associated with each of my training data sets. The main objective of supervised learning algorithm is to learn an association between my input data samples and corresponding outputs after performing multiple training data instances. So basically, now the supervised learning, that is where multiple ML algorithms will come. So the main objective of this supervised learning algorithm is traditionally to find and to learning is important here, learn the association between my input data samples and corresponding outputs. So we're going to talk about my input data samples and its corresponding outputs after performing multiple training data instances. So we will be having multiple records, record 1, record 2. Likewise, I'll be having multiple things. So the moment I'm gonna find out all of these, record 1, record 2, I'm going to perform my multiple training process on this part. So all of these individual data records will be fed as my training part, and F1, F2, F3, F4, these feature sets will eventually be correlating with my target here. Based on the ML task, the supervised learning algorithm can be divided into two types, as I was talking about. That is where we have classification type and the regression type. So basically, depending on my target, what I'm going to learn, what is my task. So for the classification types, it's more like a class I have in the objective. So what do we mean? More like whether this person is having disease or not, more like yes or no situation, or true false situation, or 0 1 kind of situation. So more like a class, I'm trying to predict whether this particular feature sets, combination of these feature sets, belong to a particular class A or it belongs to a particular class B. So what is the class of my output? That is prominently would come under a classification type of a problem. The next is we talk about regression. Regression is where we talk about a continuous number in the output. Now, what is a continuous number? Whether it is a salary, which is like say 1,000 or 25,000 or whatnot. So all of these are continuous number which can range from minus infinity to plus infinity. That is what I'm trying to focus on in my regression problem. That is what regression talks about, right? So this is where the regression comes. And now the question is, for this regression, assuming that I have built up my model, how I am going to evaluate my model, that is again very important. So how I'm going to judge how good is that learning. So we're talking about the learning process here, right? So how to identify that this learning is good or that learning is not that great. So what is the mechanism and how do we identify the learning of individual algorithms here, and how do we evaluate that which one is a better one, right? So for this, again, we have multiple methodologies and we'll be discussing about them one by one. So let's start with the first regression index, MAE, which is also called as mean absolute error. Mean absolute error. So now there is a very important term which is error here, which is on. We also call this as residual. Now, first let's try to understand what is an error. Let me open a new slide here. Just a minute. Okay. So first, let's try to understand what is an error in regression. So assume that you have a data set which you have plotted on this, and this is what my two trend of my data looks like. Okay. I have built up my classification, regression problem, and that best fit line is somewhat, going like this. Okay. So this is what my best fit line of a regression comes into picture. So now this best fit line, you can see the data points which I have from the scatter plot does not fall directly into my best fit line. So they do not coincide, right? Yeah, few points does coincide, but all of them does not. And that is where we say the difference between the perpendicular difference between the points to the best fit line is where the error is. So for the point this, my prediction is basically this, for example. And this distance from the point to my line is called as error. So suppose that original data is 100, which is say this point. This point suppose is 100. Okay. And obviously I have predicted for this perpendicular distance this point which is lesser. So predicted data would be say 95. So what is the distance between these two, or what is the difference or the residual or the error is nothing but 100 minus 95, or we can also say predicted minus actual, other way around, like 95 minus 100. So we are talking about basically the difference. If I take it the reference from original 100 minus 95, or if we take it to the reference from the predicted minus actual, simple as that. So we have a value of 5 present here as my error. So we have an error of 5 units, right? So likewise, if you see, there are so many points. So this is called as my error 1. Likewise, this will be called as error 2. This will be called as error 3. This will be called as error 4. This will be called as error 5. So howsoever, how many points we have, we will be having those many errors as well, till e to the power of n. Correct? If I have n points, I have n errors as well, because I have n actual values also and I have n predicted values also. Correct? That is where the concept of errors comes into picture. That is where we say that yes, now how the errors are in a regression perspective. So error is nothing but difference between my predicted and actual. So now look at this, go back, let's come back to this particular problem statement of ours. Look at this part. What do we say? Y minus y hat. So y is my actual output or my original data, and y hat is my predicted data. And what are we trying to find out? Y minus y hat. So basically we're trying to say the error here. Can you relate back? This is what we're trying to identify, right? Original minus predicted. This is nothing but error. Correct? So this term is basically y minus y hat. We're calling this as residual or the error term. Now, since we know that we have n numbers and data points, I have to take a sigma of this, like a summation of this, which is nothing but sigma I is equal to 0 till n. I will be taking the sum of y minus y hat. Agree? So if I have to take a sum of all of these errors, I'll simply take a summation of this y minus y hat. And that is where the techniques will be changing. So now in this case, for mean absolute error, let's read it out. So this error is nothing but y minus y hat. What we have identified, this y minus y hat is what my error term. The second term is absolute. So taking an absolute of this error, y minus y hat, and I'm taking a mean of it. So summation is my absolute error ka summation, and taking a mean 1 by n. So what is the mean? Sum of all divided by total number. So total number is n and summation is sigma n is equal to 0 till I is equal to 0 till n. I have absolute y minus y hat and I'm dividing it by n, which is my total term. And now read out this. This is exactly what mean absolute error talks about. So 1 by n of summation of my absolute error. As simple as that. So one of the very simple methodologies to identify the error or to find out what is how respective regression problem statement. So, but in this case y minus y hat. And I'm saying that if y minus y hat is my error, so taking an absolute of that, and once the absolute is taken, I'm taking a mean of that absolute error. That is what mean absolute error means. Simple. One of the very standard mechanism to find out the error of this. Second, we talk about mean square error. Again, simple. Mean square error. This is nothing but mean square error. So now we are trying to find out the mean of a squared error. Again, what is an error? Y minus y hat, or we can also say actual minus predicted. So for all of these actual minus predicted, we are now squaring this. Can you see them? So the error is now getting squared here. So square of my error is what I am trying to find out. So square of my error, and I'm taking a mean of it. Same thing. So I'm still taking the error y minus y hat, sum of all errors. But here the error would be squared error. Problem, mean absolute error. This error was actually an absolute error. And in this case, it's a squared error. Let's take a quick example. How can we see the example also? Suppose remove this part. Okay, so suppose this is my original data. Okay. So we find out error. Just a minute. Okay, so the error, absolute error, and squared error. So I have say 100, predicted is 95, say 200, predicted is 210. Now original is say 150, predicted is 150, actual is say 250, predicted is 270. So what is an error here? Original minus predicted 5, original minus predicted minus 10, original minus predicted 0, original minus predicted minus 20. So what is an absolute error? 5, 10, 0, 20. What is a squared error? 25, 100, 0, 400. So what is a mean absolute error in this case? Mean absolute error is nothing but sum of all of these absolute errors. So 5 plus 10 plus 0 plus 20, which is 35. This is equal to 35 by number of variables 4. So this will come out to be 8.75. So that is going to be my mean absolute error, 8.75. And if we try to find out a mean square error, that is nothing but sum of these square errors. So 25 plus 100 plus 400. So 500, 500 plus 25, so 525 divided by 4, which is coming out to be 131.25. Can you see the difference? So mean absolute error is 8.75. Mean squared error is 131.25. That is how the two indexes, mean absolute error and mean square error, is defined. The second standard mechanism, the third standard mechanism is root mean square error, which is nothing but root mean square error. So the same mean square error which we calculated earlier, we are going to take a root of that. That's it. That is nothing but root mean square error. Again, the same concept. Error still remains the same. Y minus y hash, nothing but the square part. I think the square is missing here. So square of my error, and then summation of all of it divided by n, taking the mean and taking a square root of this, is nothing but my root mean square error. If you go back here in this same calculation, so then the RMSE would be nothing but under root of MSE or under root of 131.25 or somewhere around 11.25 something. So RMSE becomes 11.25. Right? So that's how we define the points of my mean square error, root mean square error, mean absolute error. So we have to understand each of these are some or the other way the metrics which are used for my calculation. Pretty simple, straightforward. They all are based on the error calculations. So basically, what is an error? Actual minus predicted. And the moment I have a data point, the moment I have an error, the actual minus the predicted value, I'm trying to find out the absolute of it, I'm trying to take the square of it, and I'm trying to take a root mean square error of it. Okay, so that's pretty much what MSE means. Now, another we have is R squared. So R squared is again another metric that tells the performance of my model, not the loss in an absolute sense. That means it is going to tell how did my model is performing. It is pretty simple formula, which is nothing but we're going to find out the sum of squared error, again error, sum of squared error of a regression line and sum of squared error of a mean line. So this sum of squared error of a regression line will be divided by sum of squared error of a mean line, and we're going to take one minus of it. That is going to be my R squared here. Simple. Another mechanism to identify my regression index. The last is my adjusted R square. Again, an interesting factor. It is more like advanced R square. So what it does is it tries to keep a check if we have any unwanted feature which is added to my data set. So generally what happens, If we keep on adding up new features, there is a probability that we might increase our model performance. We might end up explaining more variance, but there has to be a limit. So there, it is more like it adds up a penalizing factor when there is an unwanted feature which gets added to my model calculation. So can you see this? R adjusted is being defined as 1 minus of n minus 1 divided by n minus k minus 1 multiplied by 1 minus r square. So r square is still the same calculation, but now we have two more terms, n and k, where n is the number of observations, like by number of rows, and k is the number of columns. So it takes the factor of rows and columns, how many rows, and based on that, how many columns are given. And then it tries to adjust my R square if the ratio of my rows and the columns are not in a sufficient fashion. So it is going to add a penalizing factor if it is adding, multiple too many data points calculation part. So that is where this adjusted R square comes. So both R square and adjusted R square, they are used equally and they have their own respective importances in my data calculation. And that is where we will be saying that how good my model performance is depending on both of these individual factors. Cool. So that's it, guys. So this is what we have from the index perspective of regression. So this is what I intended to cover. And anyway, much detailed of all of them will be following up in our respective discussions. But this is what I intended to cover, talking about my respective regression indexes. And now, with this, I'm pretty much done, guys. As always, I'm open to questions. If there is any question, I will be more than happy to take it. So please feel free to reach out and type in your question. Let's take it up if you have any. Of them will be following up in our respective discussions, but this is what I intended. The respective regression indexes. Cool, guys. So with this, thank you so much for being patient and listening to me. So we are done with our today's discussion. See you in the next video, guys. We'll come up with another set of classification indexes now. So like the way we discussed on regression, we'll again quickly discuss on the classification indexes as well. Thank you so much, guys. Have a good day ahead. See you in the next video. Bye-bye.